In this video, we evaluate the integral of cos inverse of x with respect to x. We know that derivative of cos inverse of x or d dx of cos inverse of x equal to minus 1 by root over 1 minus x square. However, we want the integral of cos inverse of x. We can do it by applying product rule of integration. Let's recall what is product rule of integration. If we want to evaluate the integral of product of two functions u and v, that is given by first function, which is u, integral of second function, that is v dx, minus integral of derivative of first function, that is u dash, to be multiplied with integral of second function v dx, and this whole expression has to be integrated once again. The whole expression, this whole expression need to be integrated once again, that is product rule. And we want to apply product rule, and further we want to make sure that we decide which one is the first function and which one is the second function. However, you see that you got only one function, which is cos inverse of x. What shall we do? The answer is pretty simple. Cos inverse of x can be written as product of cos inverse of x and 1. Yeah. So we got two functions, cos inverse of x and 1. So we can apply product rule of integration. Now we need to decide which one should be our first function. For that we got something called ILATE rule. I-L-A-T-E. ILATE rule. I stand for inverse trigonometric function. L stand for logarithmic function, A stand for algebraic function, T stand for trigonometric function, and E stand for exponential function. Which one do we find first? Well, obviously we find inverse trigonometric function to occur first, and so we regard inverse trigonometric function to be first function, or we choose u equal to cos inverse of x and then v equal to 1. And so we need to determine integral of v dx, integral of v dx, integral of v dx equal to integral of 1 dx, which is equal to x plus some constant, but in this case we don't have to write that constant. First function cos inverse of x, integral of 1 dx, integral of v dx is simply equal to x minus integral of derivative of first function, derivative of cos inverse of x, which we have seen earlier, is equal to minus 1 divided by root over 1 minus x square. And then integral of second function, integral of v dx is integral of 1 dx is just x dx. Everything needs to be integrated once again. Let's simplify the expression. We got x cos inverse of x. Negative of negative is positive. Integral of x dx 1 by root over 1 minus x square. So we got two expressions, x dx 1 by root over 1 minus x square. How can we do it? Observe that d dx of 1 minus x square is simply equal to minus 2x. Or we can say that d of 1 minus x square equal to minus 2 times x dx, or minus half of d of 1 minus x square equal to x dx. So we can write the integral of cos inverse of x is cos inverse of x times 1 dx is equal to x cos inverse of x. And then this expression, you see that I can write this expression x dx, this expression x dx is simply minus half of d of 1 minus x square. Let's do it. Plus integral, we copy as it is, 1 by root over 1 minus x square we copy as it is, x dx, we simply write it as d of 1 minus x square, of course along with minus half that we can write outside of the integration. Okay, now we get an expression like x cos inverse of x minus half integral of 1 minus x square to the power minus half d of 1 minus x square. Now we can apply power rule and say that this is equal to x cos inverse of x minus half as it is. Integral of u to the power n du is u to the power n plus 1 by n plus 1. Minus half plus 1 is plus half. So 1 minus x square to the power plus half divided by plus half plus some constant of integration. Again, minus half and plus half can be cancelled out, and so we get the final answer equal to x cos inverse of x minus root over 1 minus x square plus some constant of integration.